Okay, today we're going to do section 6.3. We're going to continue talking about factoring. Today we're going to talk about factoring squares problems and cubes problems. So if you'll take out your notes, please. We're going to do 6.3. And just like we've started every single section so far this chapter, I want you to start by listing me the steps of factoring. Anytime I ask you to factor, or anytime I ask you to solve by factoring, you should always be following the same steps. So if you can, please, fill out the steps for factoring. The first step, anytime I ask you to factor, is you always want to put the problem in order. Okay? In order, meaning everything to the same side and your highest exponent to your lowest exponent. Make sure everything's in order. Your second step is you need to look for a GCF, a greatest common factor. Is there something you can take out of each term, whether it be a number or a variable? Can you take something out? If you can, you need to do it first before you do anything else. Okay? The next step happens when you have two terms. When you have two terms, you're either going to do squares or you're going to do cubes. We haven't talked about it yet, but that's actually what we're going to do today. So today we're going to factor things with two terms in them. Okay? The next two steps happen when you have three terms. If there are three terms in your problem, you are either going to basic factor, figure out what number multiplies to the last number that adds to the middle number, or you're going to bottoms up. And I bottoms up when there's a number in front, right, that you can't GCF out. You're going to bottoms up. The last step is when you have more than three terms. So let's say you have four terms. When you have four terms, you're going to factor by grouping. Anytime I ask you to factor, or later on when I ask you to solve by factoring, you should be following these 6 steps all the time. Okay? So what I'd like you to do when you get your homework and when you get your test is write out these 6 steps. That way you can go through and check off that you've done them step by step by step. Okay? All right, let's do some problems. These problems are going to look a little bit different than what we're used to. If you look at this first problem, how does A look different than some of the problems that we've been used to? Isn't there no middle term? I have an x squared, and I have a minus 36, but I don't have an x term. So what number could I plug in there so that I do have an x term? If there is no x term there, what number can I plug in to make it there? Can I plug in a 0? Right? Because normally we don't write 0x. We just don't write anything at all. Right? But if you wanted to force an x term to be in there, it would be a 0. So now how many terms do I have? 1, 2, 3. I have 3 terms, right? And so can I do basic factoring? To do basic factoring, I need to figure out what numbers multiply to negative 36, that when you add them together now you get 0. So what numbers, when you multiply them, give you negative 36, but when you add them together you get 0? Did I say positive 6 and negative 6? Doesn't that work? Multiplying them together, I would get negative 36, but when I add them together, I get 0, right? So my factored version of this problem would be x plus 6, x minus 6, okay? Is there anybody that can tell me a shortcut, instead of doing that middle step, how can I go from here to here without having to write the 0 term in there? Can I take that x squared and just separate it? One x in one parenthesis and x in the second parenthesis, so breaking up the x's? And then can I take the 36 and kind of take the square root of 36? What's the square root of 36? 6. So can I do 6 in this parenthesis and 6 in this parenthesis? And then I only have to do from there is figure out what signs have to be. And if I need them to multiply to a negative 36, isn't one of them always going to be positive and one of them always going to be negative? Okay? This is called the difference of squares problem. Okay? When I have two terms, and I have a subtraction sign in between, and I have a number that is square rootable, I think that's a word, square rootable, what I can do is I can factor them by breaking up the x squared and by taking the square root of that number. So what's the square root of 25? 5, right? 1 being positive, 1 being negative, that would be a factored version. Okay, it's called a difference of squares problem. When you see two terms, that's what you're always going to try first. You're always going to see first if it can be broken down into a squares problem. If not, then maybe we'll have to try something different. Let's look at B. Is it in order? Looks like it. Is there a GCF? Yes. What number can be taken out of 4 and 64? 2 does, but can I even go higher than 2? Can I go 4? Doesn't 4 go into 4? And doesn't 4 go into 64? So if there is a GCF, then I need to take it out first before I do anything. It will make a difference in your problem. So please make sure that you always look for a GCF first. If I take out a 4, then I have left over an a squared minus, how many times is 4 going to 64? I think 16, right? Don't stop. We need to make sure that we factored all the way down as far as possible. So if you look inside the parentheses, how many terms do I have? I have 2, right? And I have a subtraction sign in between. And what about that 16? Can I take the square root of 16? Can't I? So it looks like this is factorable more than it already is now. So let's take the inside of my parentheses and let's factor it even more. I'm going to take the a squared and I'm going to break it down. I'm going to put an a here and an a here. And then I'm going to take my negative 16 and I'm going to break it down to what? Square root of 16 is 4, right? So a 4 here and a 4 here. And what do my signs have to be? 1 positive, 1 negative, because I need to multiply to a negative 16. When I add them together, I get 0. That's why there is no middle term. This would be my final answer. Making sure you have that 4 out in front. Your GCF doesn't disappear. It's still there. And then you have an a plus 4 and an a minus 4. Okay, let's keep going. Let's try another one. Look at this one. It's a little bit different. Is it in order? I guess. Right? Kind of hard to tell, but it looks like it's in order. We got an m squared and a p squared. Is there a GCF? Is there a number I can take out of 16 and out of 49? I don't think there is, right? Can I take an m out of both of them? No, the second one doesn't have an m, so I can't take out an m. Can I take out a p from both of them? Nope. So it doesn't look like there is a GCF. So then my next step is to see how many terms there are. Looks like in this problem there are 2 terms. If there are 2 terms, let's see if we can break it up into a squares problem. In order to break it up into a squares problem, I need to be able to break up this stuff evenly. So let's look at the first term. Let's look at the 16m squared. How could I break up a 16m squared so that it's equal in both parentheses? I don't want to do 8 and 8, because if I were to FOIL that back out, what is 8 times 8? Isn't that 64, not 16? So what number, the same number, multiplies to get me 16? AKA, what's the square root of 16? Could I say 4 here and 4 here? But I don't just have a 4 in the front there. Don't I also have an m squared that I need to break up? So can I really say a 4m and a 4m? Because that way, if I were to FOIL it back out, what's 4m times 4m? Isn't that 16m squared? All right, so I need to do the same thing with this second term. Let's see if we can find a way to take my 49p squared and break it up evenly. So how would I take a 49 and break it up evenly? What's the square root of 49? Can I do 7? And not just 7, but I also have a p squared. So can I say 7p here and 7p here? What do my signs in the middle have to be? 1 positive, 1 negative, right? So that if I were to FOIL it out, I would get a negative 49p squared. Because 1 is positive and 1 is negative, the middle terms are going to cancel. That's why I have nothing in the middle, no MPs in the middle. This would be my final answer. Okay? Another one. This one looks a little bit different, right? This one looks different because I have an x to the fourth in there. It's written in order. There is no GCF. How many terms are here? 2. If there are 2 terms, we're going to try to break it up into a squares. In order to be able to break it up into a squares, I need to be able to break it up evenly. So, before, we had an x squared, and we broke it up into an x and an x. So now that we have an x to the fourth, how do you think we can break that up evenly? Could I do an x squared in each of them? Right? Couldn't I do that? X squared times x squared would be x to the fourth, which is what I need. So now I just have to figure out how to break up that 81. What's the square root of 81? 9. 1 positive, 1 negative. That is not your final answer. Anybody see why? Can I still factor? Can I still factor these? Can I factor both of these? Be careful. I cannot factor the one with the plus sign because there are no numbers that multiply to positive 9 that when I add them together give me 0. The only way that I can factor it is if there's a negative sign in between. I can take this x squared minus 9 and I can break it up into x and x, and I can break it up into 3 and 3, 1 positive here, 1 negative here, because if I were to multiply those I get a negative 9, but if I were to add them together I get 0. The only way that I can factor a squares problem is if there is a subtraction sign in between, okay? So this would be my final answer. When I ask you to factor, I want you to factor as far down as possible. So please don't stop at the black step. Make sure you go down again and factor again to the red step. Okay? Your final answer would be x squared plus 9. You should have an x plus 3 and an x minus 3. Okay? Squares problems happen when you have 2 terms. You're going to see if you can break it down evenly. If you have 2 terms and you can't break it down evenly, then maybe it's called a cubes problem. Okay, so let's look at the next thing. Cubes problems also happen when we have 2 terms. Okay? And in order to tell if it's a cubes problem, your problem needs to be able to be written something cubed minus something cubed, or something cubed plus something cubed. It needs to be 2 terms, and both of those terms need to be something cubed. Okay? There is kind of a formula that we're going to use to help us factor cubes problems. Okay? If there is a subtraction sign in between, we're going to use a certain formula. And if there is an addition sign in between, we're going to use a different formula. But they all kind of have the same pattern. So this is how I remember it. The first part is going to have a small parenthesis, then I'm going to have a bigger parenthesis behind it. I'm going to always start with my signs. If it is a subtraction sign in between, I'm going to do the same sign. I'm going to do opposite signs. I'm always going to be a plus sign in the back. Same, change, plus is how I remember it. Okay? I'm going to have the same sign, subtraction sign. I'm going to change my sign, so the plus sign, and then I'm going to do a plus sign in the back. Same, change, plus. From there, all I have to worry about then is filling in the little spots, filling in the terms. Okay? This first one is going to be my first term. So if I have an x in the first part, I'm going to have an x in the first part here. My second one is going to be my second term. So if my second term is y, then I have a y that goes right there. So I have my first term, I have my second term. Okay? This one is going to be my first term squared. So my first term is x, I'm going to square it, so I really have an x squared there. It's my first term squared. This term is going to be my 2 terms multiplied together. So x times y, I'm just going to call it xy for now. My last one is going to be my second term squared. My second term was y, so when I square it, I get y squared. Okay? So one more time, I start with my signs. I do same, change, plus. Then I fill in my terms. First term, second term, first term squared, the 2 terms multiplied together, and my last term squared. You're going to do that same thing all the time. Anytime I have a cubes problem, that's the formula that you're going to use. Even if it's a plus sign in between. If it's a plus sign in between, we're going to use that same pattern. If it's a plus sign in between, we're going to do same sign, change the sign, plus sign, same, change, plus. Then I'm just going to fill in my terms like I did before. I have my first term, which in this case is an A. I have my second term, which in this case is a B. I have my first term and my second term. Now I have my first term squared, A squared. Then I have my two terms multiplied together, A times B. Then I have my last term squared, B squared. Okay? It's just a pattern that you have to memorize. The more you do it, though, the better it'll be. This is how we factor cubes. Let's do some. Let's look at example number 1A. Okay? Is it in order? We're always going to check this first. In order. Yep. Second thing we're going to look for. GCF. Is there something I can take out of both those terms? No. The next thing I'm going to look for is see how many terms I have. In this case, I have two terms. So if I tried to do squares, so if I thought this were a squares problem like the last few examples, how could I take an m to the third and break it down evenly? And we don't want to do decimals. It doesn't quite work, does it? Right? So I know right off the bat that this is not a squares problem because I can't take the 3 and break it up equally. And I can't take the 8 and take the square root of 8 and break him down equally. So it's not a squares problem. So the only other problem it could be is a cubes problem. But in order for it to be a cubes problem, it needs to be able to be written something cubed minus something cubed. And right now, the only thing that I see cubed is the m. Right? I don't see an 8 cubed, I just see a regular 8. So what we have to do is we have to rewrite this problem so that it says something cubed minus something cubed. So the m is cubed, but what can I make the 8 so that instead of an 8, it's something cubed? So what cubed is the same thing as 8? Did I say 2? Right, isn't 2 cubed 8? 2 times 2 times 2, doesn't that give me 8? So now I have my something cubed minus something cubed. I have my first term, I have my second term, and I can use my formula. Okay? Let's start off with our little parenthesis. Let's put our big parenthesis, and let's worry about our signs first. Same, change, plus. What would go first? Negative sign, right? Same sign. Change, plus. Same, change, plus. I've got my signs filled in. Now all I have to do is worry about plugging in the blanks, filling in the terms. Are you ready? Here, I have my first term, which is m. Here, I have my second term, which is now 2, right? This is my first term, this is my second term. Here, I have my first term squared, so what would go here? M squared. In the middle, I have my two terms multiplied together. So I have my m times 2. So can I really just say 2m instead of m2? It looks a little bit more normal to have the 2 in the front. All right, the last one is my second term squared. What was my second term? 2. And if I square it, I'm not going to say 2 squared. I'm going to say 4. Okay? So please don't write it 2 squared. Make it just a regular number. Make it a 4 for me. This is the factored version of this problem. You can't factor it anymore. This would be the final answer. You can't find any numbers that'll multiply to 4 that add to 2. So this is your final answer. Once you factor using cubes, you should not be able to factor anymore. So that is it. Okay? Let's try a few more so we get the hang of it. Let's look at B. Always follow your 6 steps. So my first step, is it in order? My second step, is there a GCF? Is there a number that I can take out of 27 and 125? 2, no. 3, No, I don't think 3 goes into 125. 5, no. I don't think there is a GCF, right? If there's no GCF, then I'm going to go down to step number 3. I'm going to see how many terms there are. In this problem, I have 2 terms. So in this problem, I'm either going to do a squares or a cubes. Let's try squares first. If I tried to do squares, and I tried to break these up equally, can I take 27 and break it up equally? Is there a square root of 27? No. So it wouldn't work, right? So I know that this is not a squares problem. The only thing that it could be is a cubes problem. But in order to be a cubes problem, I need to be able to write it like this. Something cubed plus something cubed. And right now, the only thing that I see cubed is the z. Don't you agree? So we need to do some rewriting here. I need to somehow rewrite this so that I have everything cubed. Something cubed plus something cubed. So how am I going to rewrite my 27 so that instead it is something cubed? What cubed gives me 27? Could I say 3? Isn't that the same thing as 27? 3 cubed is 27? All right. Well, then that means I need to take this 125 and figure out how I can rewrite him so that it's something cubed. So what times what times what gives me 125? Does 5 work? So now, this looks a little bit more like my cubes problem. I have a first term, 3z, and I have my second term, 5, and now I can use my formula. I want you to plug in the signs for me. Let's not worry about any numbers, let's just plug in the signs. So will you plug in the signs? Same, change, plus. Go. Same, change, plus. Okay? Now we need to worry about filling in our terms. You ready? I have my first term, 3z. I have my second term, 5. Okay, careful with this. I have my first term squared. My first term was 3z. So if I square it, what do I really have? Don't I have a 9z squared? Because I'm not just squaring the z, I'm squaring the 3 also. So I really have a 9z squared. Okay? The middle one is the 2 terms multiplied together. So I have a 3z times 5, so can I say 15z? And the last one is the second term squared. What is 5 squared? Let's say 25. This should be your final answer. You cannot, even if you tried to bottoms up, you are unable to factor this any farther, so this would be your final answer. Okay? I'd like to do one more. Looks a little bit different. I want to see if I can trick any of you. I'd like you to try this one for me. Factor this one for me, please. You try it. Doesn't hurt to try. I want you to try something. Let's see if I can trick any of you. Is it in order? Yeah, looks like it. Is there a GCF? Ha! Isn't there a GCF? Can I take out a 3 from both of those? If I take out a 3, then I have left over an x cubed. How many times does 3 go into 192? 64? You have to take out your GCF first. If you didn't, you probably got stuck, didn't you? Right? Because there is no way to break down a 3. Not with squares, not with cubes, nothing. So make sure you take out a GCF first. Now don't stop here. We're not done. We still need to see if we can factor a little bit more. So let's look at my inside stuff. Inside here I have an x cubed. I can't break it up evenly, so it's not going to be a squares problem. So let's see if we can make it into a cubes problem. In order to make it into a cubes problem, though, I need everything to be squared. I have an x, I'm sorry, not squared, cubed. I have an x cubed, but what would I make this 64 into? What cubed gives me 64? Not 3, not 5. Does 4 work? Now don't forget about the 3 in here. My GCF is still there. I'm just going to leave it out front for right now. And let's just worry about doing my cubes problem. Okay? Little parenthesis, big parenthesis. You fill in your signs, and you fill in your terms, and I'll catch up with you. Fill it all in for me, please. Oh. There we go. Did you get that? Same, change, plus. My first term, x. My second term, 4. My first term squared. My 2 terms multiplied together. And my last term squared. 4 squared is 16, not 8. Not 4 squared, but I'm going to call it 16. I have this as my factored version. What am I missing? Aren't I still missing this GCF out in front? I'm going to smush it up there. And this will be my final answer. Please don't forget the 3 out in the front. It does make a difference. If you were to FOIL this out and not put the 3 there, you would not get the correct answer. Okay? So don't forget about your GCF out in front. This is your final answer. You should have a 3. You should have an x plus 4. And you should have an x squared minus 4x plus 16. Okay? Anytime we factor, what's step number 1? Put it in order. What's step number 2? GCF. If there's a GCF, you have to do it first, just like we did on that last example. You get stuck sometimes if you don't. So please GCF first. The next step, you're going to look to see how many terms there are. If there's 2 terms, you're going to try squaring first. Can you break it up evenly? Just one positive, one negative. If not, then you're going to try your cubes. Okay, can you make it into something cubed plus something cubed, or something cubed minus something cubed, and then use the formula. If there's not 2 terms, let's say there's 3 terms. What do you do if there's 3 terms? Either basic or bottoms up, right? Bottoms up if there's a number in front. And if there's 4 terms, what's the last type of factoring? Grouping, right? Every single time you factor, you should be following those 6 steps. Okay? All right. Your homework tonight is going to be 6.3 worksheet. Please make sure that you're working and you're behaving yourselves. I promise I'll make it worth it to you if you get a good report for today, okay? All right. I'll see you guys tomorrow.